Good morning, everyone. As long as this is the first time we are meeting in this day today, so it can be good morning. If not, you can say good noon or afternoon, maybe. Still, it is not evening. Yeah, but let's continue. So we are continuing the arrays, right? Derived data type array. What is array? Let us quickly revise it. So array is nothing but a collection of elements having same data type. It is having a continuous memory allocation, right? And we can access all the elements within the array using index values, subscripts. Index always starts with 0, and we can iterate it. We can write a loop to go through all the elements. We can have single dimension array or 2-dimension array or multi-dimensional array also. So a one-dimension array, we have seen how we can declare one-dimensional array, how we can assign values at let's say compile time, at runtime, and how we can use those elements to store values and make some calculations. After that, we had gone for two-dimensional array. So 2D array is nothing but kind of a table or a matrix. How to declare, how to assign values, we have seen, and then we have gone for number of programs related to matrices. The last program that we had seen was this one, the matrix multiplication. So we tried to understand the entire process of matrix multiplication first, and then we tried to find out a pattern in all those calculation processes. So once we found that pattern, we come up with this logic. So this is what we can write in a program to multiply two matrices labeled with A and B. And this program was only for 3x3 matrix, right? So at present, this is the program which has been written for 3x3 matrix, and that's why we had these loops up to 3, 3, 3, 3, 3, and 3. Okay. But if you want to generalize this one, then outer loop is for row, inner loop is for columns, and the nested loop of k is going to give you the number of summations. Okay. So if you try to still understand this thing, then let us take an example, and then you tell me what should be the limit for I, j, and k. So if I say that I have matrix A, which is 2 cross 4, okay, and I have matrix B, which is 4 cross 3. Now tell me, if I multiply these two matrices, what will be the size of matrix C? Just respond in the chat box. What will be the size of matrix C? Yeah, 2 cross 3. That's correct. Very nice. Very nice, everyone. So 2 cross 3 will be the resulting matrix C. Now tell me, what will be the range of I from 0 to question mark? What will be the range of J from 0 to question mark? And the range of K from 0 to question mark? So first, tell me what will be the range of I. I equals to 0, I less than question mark. What should be there? Yeah, that's correct. 2. And that's going to be the row of A. So this one is going to be 2. Then range of J will be what? J less than 3. That is also correct. Now you can easily identify this thing By simply understanding I is row, J is column, and we are calculating matrix C. So C has a row 2 and the column 3. That is also possible. This is how you can also identify the loop of I and J will range from 0 to up to what number, because Cij is what you are calculating here, right? Cij, and the range of Cij will be from 0 to 2 and 0 to 3. And the constraint that we follow, that we check actually before we multiply two matrices, is what? Number of columns in matrix A should be equals to number of rows in matrix B, and that is actually the number of summation iterative process we will go, and that will be the range of K, which will be 4. Okay, so this is how you can decide what your loop should go for. When you write multiple loops here, then definitely you need to write some conditions, and you can define your conditions based on this analysis, right? So we have seen this thing, matrix. We earlier we had seen matrix addition also, then we had seen matrix multiplication also, and we have completed matrix multiplication program also, right? So that's the two-dimensional matrix. Now let us see multi-dimensional matrix theory part 1, and then what we'll do is we will go for in the remaining part of today's lecture, we'll go for a few programs here. Okay, still we will do few more programs on two-dimensional matrix or one-dimensional matrix and so on. So we want to learn multi-dimensional arrays, or not matrix but arrays. Now this is not exactly the part of your syllabus. Your syllabus does not have this multi-dimensional array topic, but what I believe is you should be knowing that there is no limitation on dimensions. If you can visualize, if you can handle that code, then you can have any dimensions inside your program. So multi-dimensional arrays are nothing but, again, data type, then array name, and then the number of dimensions you want, the number of sizes you are going to define here. So size 1, size 2, size 3, up to size n, if you want n dimensional array here. So if we take an example of the earlier cube matrix, that cube that we have understood at the time of starting of this unit, okay, then you can take it like this way. You have 3 layers, okay, 0, 1 and 2. So if I say this is my array ARR, then ARR has 3 layers first, then each layer, you can say, is having 4 rows, okay. So the second dimension is number of rows, 4 rows. And if I say that each layer is having 3 columns, something like this, then the third dimension will be the column size 3. And I can say this is going to be integer array and done, right? So this is how you can visualize that thing. 3-dimensional array, okay? So this can be layers, and in each layer you can have rows and columns. So you have row and column, which means it is 2-dimensional array, and you have multiple layers of those rows and columns. That is going to be your third dimension. Now up to 3 dimension you can visualize like this one, having a cube, okay. So you can visualize it. Now it is also possible you may go for 4 dimension, 5 dimension, 6 dimension and so on. If you require, then you may go for it. Now it's not easy to visualize, but let us try to understand where do we require 4 dimension or something. Yeah, dimensions is Vyom is asking, sir, what exactly does this dimensions mean? A dimension means anywhere we live in a three-dimensional world, right? Everything that we see or that we have is in a three-dimensional space. So if you want to understand dimensions in physical world, we can say height, width, and depth. Okay. So similarly, your data can also be represented in multiple dimensions. For example, let's have it here. For example, if you have single value, okay, if you have a single value, then you can say it's a singular unit value. I need not to go for any dimension here, or I can say that this single value is in any dimension. But when I say there are multiple values, then I can say it's a series, right? 1, 2, 3, 4, and so on. It's a series. It is being increased in one side, one dimension. Okay. So when I say this is increasing in one dimension, whenever I introduce it in a dimension, I need to define one plane actually. So on this place, let's say I'm increasing it in one direction. So one, I have to define this place. That's my first dimension. And in the second dimension, I'm increasing it. Okay. So that is my second dimension. So when I define this two dimension, I can have multiple series like this way. Now, if I have only one series, then I can say it is one dimension, 1D array. But when I have more than one series like this way, I need to go for 2D array. Okay, this is something like this is one dimension only, but when I increase number of series, it is going to be the second dimension. So whenever I say I have a tabular data, then I have rows and columns. So that's going to be two-dimensional array. So whatever data I can store in a single table, it is two-dimensional array. But if I require multiple tables, then it goes for three-dimensional array. And again, all those multiple tables are for one entity. Now, similar entity, I require other set of tables, then it goes for the fourth dimension and so on. Right? So let us understand how we can go through multidimensional array and declaration part and all. And then we will see a few more examples also, examples of data. With example of data, we will understand what is 1D, 2D, 3D, 4D, and so on. Okay. So how do we declare? Well, we have already seen there must be data type and then array name. And after that array name, you are going to define number of subscripts or the indexes. At the time of declaration, those subscripts are actually the size of your array. Now, if you have one subscript, then it is 1D array. If you have two subscripts, then it is 2D array. If you have three subscripts, then it is three-dimensional array. If you have four subscripts here, then it's going to be four-dimensional array and so on. Okay. How many number of elements it can store? So it is going to be equal to multiplication of all your dimension sizes. Okay. If it is 3 cross 3, 3 rows and 3 columns, 3 multiplied by 3, 9 elements. Similarly here, we can say this is going to 3 multiplied by 5 multiplied by 6. Total 90 elements this array can store. 90 elements it can store. And you can represent it like there are 3 layers and each layer has a 5 row and each row will have a 6 columns in it. So that's how you can understand it, right? So this is going to be something like you are going to have total 6 columns. 6 columns. Okay, then 5 rows, something like this. So first row, second row, third row, fourth row, and one more, fifth row. Okay, and 3 layers of such kind. Okay, so this is your first layer, and then second layer, and then the third layer also, something like this. Okay, so this is going to be 3 cross 5 cross 6, total 90 elements. Right, now 3-dimensional entities we can represent here by just drawing it, because we live in a 3-dimensional world. 4th dimension, if you go for theoretical part, you can say time is the 4th dimension in our world, and time which we cannot see directly, and that's why it's not possible to draw it here. But this 4-dimensional array is also possible, where you can say you'll have 3 columns, 5 rows, such 4 layers, and those 4 layers are represented in 5 different time. At 12 o'clock it is something like this, at 1 o'clock it is something like this, at 2 o'clock it is something like this, and so on. So values may change, right? So that is just a kind of understanding. If you compare this thing with the real world, then time can be the 4th dimension. In terms of data, we will see other examples, right? But this is how we can declare data type, variable name, and then the number of sizes that we want. Total elements will be equals to the multiplication of all your sizes, all your dimensions. So those many elements you can store inside your array. Okay. So now before we move on to other examples and programs, let us quickly understand how and where arrays are good for us and bad for us. It has multiple advantages and disadvantages, right? So in array, the advantages, we can have a random access by just defining the index value. So any element can be accessed directly if the position of that element is known. Position means index, right? Easy to use, and we can store multiple values with a single variable name. Just like this one, I can store 300 values by just having a table variable name. But instead of that, if I go for 300 variables, then it is very tedious task to declare those variables and remember which variable stores which value. So instead of that, we can have only one array name, and with that reference, we can store multiple values inside. So these are few advantages. Disadvantages is it gives you the sequential access only. If you do not know the position of element, if the position of the element is not known, then you compulsorily have to go for sequential access, and you have to search your element inside the array. When you declare, you have to be you have to define it with a fixed size, constant value, constant size. So when you declare, the subscripts, the sizes are going to be the numeric constant, and later on you cannot change the size of your array variable. Size cannot be changed at runtime. Okay, so that's one thing, which means if you cannot change the size, which means your elements are fixed, number of elements are fixed. So you cannot increase or decrease your number of elements at runtime. Look, I'm saying elements, I'm not saying values. You can change values because it is a variable, but I'm saying elements. If you have declared your array of 5, which means it has 5 elements, and those 5 elements are fixed. Later on, you cannot say that I want to store 6 elements inside this one, or let's say I only want 3 elements. Let me delete 2 elements. That's not possible. So in that perspective, array has a constant size. Now, as long as it is a constant size, if you do not know the actual number of values that you are going to store, then it might be possible that you may waste your memory. So if you have declared array of 10, and if you are utilizing only 4 elements, then other 6 elements are simply wasted, right? So if your size is much larger than the requirement, then you will be simply wasting your memory. So these are some of the disadvantages of array, right? So what we have seen till now is we have seen the concept of array, one dimension and two dimensional arrays, its declaration and initialization arrays, and we have seen number of programs. And as I said, today also we will be going for a few more programs before we start strings. So we'll be starting strings from the next lecture. Let us have a look at few more programs. Let us go for a few more practice on arrays. Right? So now we will have we will have an example starting from 1D array, and we are going to eventually increase the array sizes, requirement of those things. So first of all, let's say I'm thinking of creating a result. I'm thinking of creating a result for one student. Okay, result of student, one student, let's say, and having, for example, 4 subjects. Okay, so when I say, and I also want to store data. Okay, I want to store this data. So it's something like I have only one student, so I can say only student. And we are not going for student name right now because we don't know what is strings. So right now we will only say student. And I'm going to store 4 subject marks. So to store those marks, I need one dimensional array marks. And it can be subject 1, subject 2, subject 3, and subject 4. And as long as this is an array, we can have index values 0, 1, 2, and 3. So that's the marks array. Whatever subject marks I get, I'm going to store those marks here. Now, once I have a marks, I can go for total. Now, total can be single value. Okay, total can be a single value. Then I can go for percentage. Percentage can also be a single value right now. And then I can print some grade. Okay, and that grade printing, I'm not going to store it anywhere. If you want to store it, you need to define your grades first. A, B, C, D, or double A, B, BB, BC, CC, CD, and so on. So you have to define your grades. If you only define your grades in A, B, C, D or something, then single character will be okay. But if you say that you are going to store double A, AB, double B, BC, double C, CD, and so on, such kind of grades, if you want to store, then you need to go for character array. So again, character array is nothing but a string. So that we will cover in the next lecture. So that's why I'm not going for grade points right now. We will be simply printing these grades, printf and something as an answer. So this is what the structure we have analyzed, that for given for given definition, we require this thing. We are simply going to print grades. That's all. So when we analyze this thing, we come to know that, okay, we'll require marks array of 4 size. Okay. We require total, variable, and percentage variable. So we require these 3 variables, and this is the example of having one-dimensional array right now. Okay. Now marks can be float. So total can also be float, and percentage is definitely going to be float. Whether your marks are integer or float doesn't matter. Percentage will always be in a float. And right now we assume that all these subjects are of total 100 marks. Okay. Total marks for these subjects are 100, 100, 100, and 100. If you have different marks range, then you can already ask user to enter 4 subject total marks, and then you may go for obtained marks. That is also possible if you want. And in that case, total marks will be different than the total obtained, right? So that also you have to take care of. So in that case, marks will be different than the marks obtained. Total will be different than the total obtained. That can also be done. Let us go for it. Marks obtained, total obtained, right? Percentage will be calculated. So all these are the obtained marks and obtained total, but a simple marks of every subject we are going to store somewhere. So it can be sorry, not 1000. 3 subject can be of 100 marks, and 4th subject can also be 80 marks. It is possible, let's say, or maybe one is of 150 mark subject, and in that case okay, in that case your total will be something different, 450. So whenever you go and calculate your percentage, you have to consider this total. Instead of 400, you have to consider 450 when you are going to calculate the percentage, right? That's how we can say these two things will be different than each other. So any confusion at this point of time? Right now we are going to have a look at example of creating a result for one student having 4 subjects and all the details for marks. Any confusion at this point? Well, in that case, let us go and try to create this program. Okay, so I'll directly jump to the code environment, and let's say we are going to create a new file here, result.c. Okay, and what we'll do is I'm going to create a comment line here. Calculate a result. Yeah, and we'll simply go for include not search.h studio.h and int main, and inside our program. Now, as you all know that what we require is we will require float, let's say let's say marks array, and that's gonna be size 4, right? So this is going to be the subject marks, or also you can say sub marks, subject marks, and you may go for camelized version if you follow that, doesn't matter. So subject marks of 4, then marks obtained for one student, so 4, then let's say subject total, single value, and total obtained is again going to be the single value. And then we require, let's say, percentage. Let's have full name, percentage. So these are the variables we require. Now we all know that we are working with array, and if we are working with array, we are going to have a loop iteration. So we will require some loop control variables. Right now I'm declaring only one. Fine. Now let us take these 4 subject marks and also calculate total subject total at this point of time, and then we'll ask for obtained marks of a student, right? So let us take those values first. So printf, and we are going to ask user that please enter subject total marks. Okay, and total marks for 4 subjects. And then we need to run a loop for I equals to 0, I less than 4. We already know that there are 4 subjects, so I plus plus, and inside that printf subject, then 1 2 3 4 such numbers I want here. So subject percentage d, and I'm going to use I plus 1, so that will print subject 1, subject 2, subject 3, subject 4, and we are going to scan those marks now. So scanf, and let us scan that value percentage f, because we have declared it float, and we are going to store it in ampersand sub marks of I. This is how we can store it. Okay, now alongside, if you want to calculate total, then what we can do is we initialize this subtotal with 0.0 float value, and here we can use that subtotal plus equals to submarks of I. Now this is how we can simultaneously make a total. So when user enters those subject marks, we are also going to calculate subject totals. So we are done with getting or gathering basic informations of subjects. Now let us go and ask user to enter obtained marks for a student, and that's going to be the similar process, right? So I'm going to copy and paste it, but here I'll say that at this place I'll say please enter student, or let's say please enter marks for 4 subjects obtained by student, and then we will say obtained marks subject 1 obtained marks, so 1 2 3 4 and so on, and we are going to change this variable now. This is going to be marks obtained, right? So percentage f marks obtained of I. Similarly, we will also create calculate a total also here. So total obtained is equals to marks obtained of I. So that's how we can also calculate the total. Now once we have all the values, right, we can calculate the percentage. This how can we have a percentage? If marks are equals to subject total, then 100%. But if total obtained marks are there, then how many percent? So you can go for that triangular process, right? If 450 marks are there, then it can be 100%. But if let's say 300 marks are there, then how many percent? So it's gonna be, let's say, total obtained multiply by 100, right? Divide by subject total. This can give you the percentage of that student. And once you are done with the percentage, you can print the result, right? And you can print the grade. Now let's forget about grade, because if you want to print a grade, we need to go for switch case. And there is one practical in your practical list where you are going to print that grade based on a subject marks. But let's say we know this percentage, and this is the only thing we want to print on the screen now. Now for a nice printing part, we can go for the formatting here. Okay, so look, this is nothing but a formatting. If you require, you can. If you don't, it's okay. So I'm going to make some formatting, and this is my heading part. So inside the heading, let's say we are printing the proper table. Okay, so we'll go for this thing. Let's say this is student, then /t. I'll make some space. After that, what difference there? Oh, I forgot to have double quote. Sorry. And same thing here. Yeah, so first column is student, then let's say subject 1, then /t will make larger space. Let us have 2 space, and subject 2, again 2 space, subject 3, 2 space, subject 4. So we have 4 subjects, then 2 or let's say 2 space total, and then 2 space we go for percentage, right? So these are the columns, and below that, now I'm going to print those values. Okay, all these values I'm going to print here. Student is student 1, doesn't matter, but at this place subject 1, I'm going to print percentage f, and let's go for 0.2f. Okay, percentage 0.2f. So marks of subject 1, then marks of subject 2, subject 3, subject 4, then at this place I'm going to have total, and at this place I'm going to have percentage. Now if I go for this way in a single printf, then I need to go for those marks, and I can have those marks like marks obtained of 0, marks obtained of 0, comma, marks obtained of 1, comma, marks obtained of 2, comma, marks obtained of 3. So these are total 4 obtained marks. Then I can have a total obtained, and after that I can have a percentage, right? And that's all. So let us complete our table. Simple printf. Let us save this code and see what happens when we what happens when we run this code, and on the output screen how it looks, right? So if I go and run this program, and let me have a full screen here. So it says please enter subject total marks for 4 subjects. Now let's say our and then the subject 1 is of 100 mark, subject 2 is of not 100 marks, 3 is also 100 marks, and 4 is, let's say, 150 marks. Then it says please enter marks for 4 subjects obtained by the student, and subject 1 obtained marks. Okay, so let's say 80, 80, 80, and 100 out of 150, and this is how it prints. Okay, so that's what the output we have. Now definitely it is not in a proper format, and that's where your printf formatting string will help you. Student, then percentage /t, 1 tab, but here it has already covered, let's say, more than 8 characters, so /t is making a larger space here. So we need to have one more /t at this place, and then all the numbers, okay, are having 2 digits after decimal point, and some of these are having 2 digits before, some of them are having 3 digits before, 3 digits before, and so on. Maximum it can have 3 digits before decimal point, right? So it is kind of 3.2 formatting structure, and if we print all these things in 5 character spaces, then we can align all these columns. Okay, we can align all these columns if we want, and if you want to have tab in between, you can have those tab also. So that's what, let us try to format here. But look, you have final answer 340 is the total, okay, and 75% is for one student. Now let us format this table a little bit, where we are going to work with formatting of printf and formatting strings here. So all these things are going to be, let's say, 3.2f fixed. Okay, sorry, I'm going to fix all these numbers to be printed in 3.2f structure. Need to have one tab here, so /t, and then I need to print all these subjects with 5 space. Okay, so this is 5 space, 4 character and 1 space ahead. Then there are 2 spaces and 2 spaces also. Let us have one more space at this place. Okay, total need not to have it. It is already 5 character, 2 space, and then okay. So let us save and see how it looks. Yeah, need to have one more /n here, correct? So we'll do that thing also. Right now, let us see how it looks. 100, 100, 100, 150, then 80, 80, 80, and 100. Yeah, so a little, almost a proper formatting. Yeah. Okay, this goes, one more space requires at this place. Yeah, subject 4. Now if you are not properly calculating those spaces, then you can always go for /t, which is going to create a tab. But if you have more number of tabs, then it will reach up to the end right side of your screen, and that creates another problem, and that's why I'm not going for number of tabs here. I simply go for space. So if I have one more space at this place, then I can fulfill this structure, and then total will have total 6. Yeah, this goes for 3.2. okay, which means total 6 characters we are printing here in numbers. and that's why we have a problem at this place. So fine, subject 4 requires one more space, total requires 2 more spaces, and then percentage I believe will be in a proper place. And then here, let's say at this place we require less n, and then almost output will be perfect. One last time, let us run, and at the end, as you can see, we have it. So 100, 100, 100, 150, 80, 80, 80, 100. Oh, again mesh up with space. Well, one space less and it will be okay, right? But this is how you can try around and try and you can print it. You can go for one more thing. For example, let me try it out. I just look 3 digits before dot, 2 digits after dot, and dot itself. So total 6 spaces I'm occupying everywhere. So this can also be kind of a percentage 6s. Okay, and 2 more spaces. Yeah, but let it be 6. So 1 and 2, and then percentage 6s. Let me try, and then I'll tell you what it is. Okay. So all these are the strings I want to print. Okay. These are the strings I want to print using printf. And it is also possible to print it like this way. So value 1 sub 1, value 2 sub 2, value 3 sub 3. So these are the strings. You'll see this thing more when we go for next lecture. But this is something like variable 1, variable 2, variable 3, variable 4, variable 5, variable 6. So if I want to print 6 values, then I must have 6 placeholders at this place. So percentage s, first string, second string, third string, fourth string, fifth string, and sixth string. And when you want to print strings, it is percentage s. And I want to print this string in, let's say, 6 character width, so 6s. And last is going to be normal one. So this is also possible. Let us try how it looks. Look, whenever you have something in your mind, you just need to try it. Whether it works or not, you simply try and have a look at it. So, oh, not here, just in the output screen. 100, 100, 100, 150, 80, 80, 80, 100. Yeah. So what happens is we have 2 tabs, and then look, 1, 2, 3, 4 characters for your string, and then 2 space before. So now, as you can see, the columns are matching here, but here we have a problem at this place also. So this can be something like 4.2 and so on. You can arrange it, but you need to try it once and then you can go for that thing, right? And let us also, as we are trying a little bit more, let us also go for, well, it's about time. Let us also go for tab also. Let me see what if we have tabs in between, whether that works or not. So simply Control Z everything. Okay. And at this place, I'm going to have a tab. So /t. And between all these numbers, I'll go for /t. Generally, tab is going to be the 8-character space always. So let us save, and let me try to run this program one more time. Just click on the output and then type it 100, 100, 100, 150. Always I give the same input, so just to make sure answer is the same, we are not mashing up with our logic, right? Well, this tab structure works proper than the other examples, right? Tab is working properly here, right? So every columns are having aligned output. Just need to have a few more equals to sign here to accommodate percentage. But this is for one student. Now, if you are ready with this much part, then definitely just by increasing one more dimension, you can create this entire program for number of students then. Okay. So if you want to have more than one student here, then look, subjects are fixed. There are 4 subjects only, correct? So you can say that this part is fixed. There are only 4 subjects, so total marks of those subjects will be fixed. So this is not going to change. But instead of one student, we want to have more than one student, then obtained marks will differ. 4 मार्क्स जो हमने गेट किए वो तो एक स्टूडेंट के हुए, अब दूसरे स्टूडेंट के अगेन 4 मार्क्स गेट करो, तीसरे स्टूडेंट के अगेन 4 मार्क्स गेट करो. सो इन दैट केस this obtained marks is going to have double dimension. मान लो कि आपको 3 स्टूडेंट्स के लिए ये प्रोग्राम बनाना है, then it is going to be 3x4. अब ये सब्जेक्ट टोटल तो एक ही रहेगा, लेकिन ये टोटल ऑब्टेन जो है ये हो जाएगा आपका सिंगल डायमेंशन एरे फॉर 3 स्टूडेंट्स, एंड यू आर गोइंग टू इनिशियलाइज इट विथ 0, and then this percentage is again going to be the 3-dimensional array, because percentage भी 3 स्टूडेंट के अलग अलग हो जाएंगे. So how you are going to take marks now? तो फिर यहाँ पे आपके लिए क्या हो जाएगा, you are going to have nested for loop, right? Inner loop for, let's say j equals to 0, j less than something, j plus plus, and we need to declare j also. Now you decide, outer loop is for row, inner loop is for column. Number of row मतलब कितने स्टूडेंट है, तो outer loop 3 तक चलेगा, inner loop is for column. So by looking at this result also you can analyze number of rows will be the students and number of columns will be the subjects. तो फिर यहाँ पे भी पता चल जाएगा कि 3 स्टूडेंट है और 4 सब्जेक्ट है. सो इनर लूप विल गो फॉर 4, 0 to 4. This obtained marks will be ij. So obtained marks will be ij, and this total will be total obtained of I. ith स्टूडेंट के टोटल मार्क्स कितने होंगे, ith रो jth कॉलम को ऐड करके आपको मिलेंगे टोटल ऑब्टेन्ड, right? So let us skip this part here, and you may try to go for this one now. Okay, try to have the same program, and in this table try to have number of students, student 1, then second row for student 2, third row for student 3, and so on. And I'll try to have one more lecture for this same program, so let's say in next lecture, we will complete this two-dimensional program, and we will try to have three-dimensional program in this thing also. So let us have a little more depth in these dimensions of a program. So in the next lecture, I'm going to again start with the same program, whatever we have done till now. I'm going to explain it because some of you have told me, sir, nathi samjhatu, farithi samajhu cha. Okay, so what we'll do is in next lecture, we will again understand this program and we'll go from the current place, right? So thank you everyone. What I suggest is do more practices on arrays. जब आप प्रैक्टिस करोगे तभी आपको ये सब ज्यादा समझ में आएगा. That's all. Thank you. See you in the next lecture now.